single day I'm gonna make something great. That's my way. Every single day I'm gonna make something great. That's my way.
Hey guys, what is up? So, what I have for you here is Project BTM. So, this was originally just supposed to be a redstone computer where I just tested an idea, and it ended up turning out better than I thought it would. So, today I'm going to show you this thing using my code. Uh, It's very similar to binary coded decimal, and in fact, it's actually not very good as a main operating code, as you would just binary coded decimal or hexadecimal. Uh, However, I know it has some use that's a little bit better than those codes, or maybe because it's a combination of those three codes that it's actually more or less like car tire, a all year round car tire, not very good at any of them. So what I'm going to do is demonstrate a simple addition problem uh, to show that this does still use binary. And then after that, I am going to demonstrate it using my code. So I just started the addition problem. I'm doing 5 plus 3, and while I'm waiting for it to finish, I can go over the two I/O devices that I added. So this I/O device, even though it looks like two, this is actually just one. This is to convert my code into binary coded decimal. And the reason why I need to do that is because it needs to be converted into binary coded decimal for it to work with the binary adders. And then, of course, after it, it gets sent through the binary, or yeah, after it gets sent through the adders, it comes back into this I/O device. And again, even though this looks like two different devices, this is just one decoder. It's just split into two because that's how my code works. Technically, there's three decoders for this one I/O device, and they all work together to convert the binary coded decimal, or the improper form of binary coded decimal, back into my code, which I have named JLC. So I'm going to be referring to my code as JLC now. And if we fly back to the user interface, we could see that it gave us 8. And just to check and make, okay, yeah. I was having an issue where it wasn't wanting to go back to line 1 properly after the addition problem or program. But I think I got that fixed. It was just one torch that I had misplaced in the program. Alright, so now I'm going to demonstrate my code. Now, this is where it's a little bit different. You actually enter the code into the user interface instead of having the computer change it into my code. Reason being is because if I don't fall out of the world, if I were to have it converted from binary to my code, I would need this giant contraption over there, and that drops my frames pretty fast when I use it. I don't know how, but it does. So I'm going to do, let's just do 15 plus 9. So this is 15 and this one is 9. Now I'm going to go ahead and hit the start button, and it is going to take a little bit for it to actually run through and finish, and that's only because of the architecture of this computer. I'm not going to be getting into that in this video right now. But I will be doing that in the next video. I will be explaining everything about this computer. I will be showing you guys how it works, and basically just taking this and pretty much just giving a full rundown of it. Uh, I already have everything about this computer typed into my actual computer, so it will be a lot easier for me to explain instead of just freeballing it like I am now. Now, as far as this display goes, this is not a hexadecimal display. In fact, this will display it in just regular numbers 0 through 9. And this display is actually made to work with my code. So that way, when a friend of mine and I do find a adder design that works with my code, we won't need these two decoders anymore, and we can actually just run a entire system just using that code. Now, again, I'm not expecting this code to be really that effective, but for it being my first code, I'm fairly happy with it. And as you can see, we got our answer, 24, which is in fact 15 plus 9. So if you have any questions, feel free to leave them in the comments below. Uh, don't worry, I am going to be releasing a video here shortly about my code as well. That's probably going to be after I do a rundown of this computer. So yeah, uh, and do be expecting a version 2 of BTM. It's coming soon, and there's two or three more types of interrupts that I would like to learn before I start working on it. I do have one interrupt into this, and let's see here. What was that interrupt called? Uh, I believe it's the halt interrupt, where it just stops the clock and waits until that it the said I/O device sends another pulse to it, or in my case, it's a pulse. That's actually exactly what this button is tied to. So I hope you guys enjoyed, and I'll see you in the next one.